For years, Detroit, Silicon Valley, and much of Wall Street treated solid-state batteries like a safe future tense, important, expensive, real in theory, but still far enough away that today's compromises could keep selling at luxury car margins. That assumption is now under direct attack. Reuters reported in April 2024 that GAC's Hyper brand said it had completed all solid-state battery R and D and planned to begin using the technology in its cars in 2026 with a claimed energy density of 400 watt-hours per kilogram and more than 1,000 kilometers of range. That is not a minor product update. That is a chemical declaration of war against the timetable Western executives have been selling for years. What makes this threat more dangerous is the body chosen to carry it. The HYPTEC HT is not a vaporware sketch or a fundraising concept. GAC is already marketing the SUV in Europe, Hong Kong, Brazil, Indonesia, and other overseas channels, while official product pages highlight its premium positioning, glowing rear doors, and sensor-heavy architecture. In other words, the battlefield is not an imaginary prototype. It is an existing luxury SUV platform with international road presence, and that is why this moment matters. GAC is not asking the world to believe in a fantasy. It is asking the world to imagine what happens when a proven premium EV receives a new heart that could make today's Western electric hierarchy look chemically outdated overnight. The American story around electric vehicles has been strangely comforting for legacy power. Consumers were told that today's lithium-ion packs were imperfect, but acceptable, that premium EVs would keep getting a little better each year, and that the real revolution, the one with dramatically higher energy density, lower fire risk, and fewer packaging compromises, was still safely parked in the late 2020s. Reuters summed up that mood at the start of 2024. Despite decades of research and billions in spending, the future of solid-state batteries still looked elusive. Tesla, the company that taught Detroit to fear software-defined EVs, had not publicly detailed any solid-state program. Toyota had pushed mass production expectations to 2027 or 2028, and Nissan said scaled production would not begin until early 2029. In other words, the industry's working assumption was simple: solid-state mattered, but not yet. That timeline gave Detroit, Europe, and even many investors a psychological shelter. It implied there was still time to amortize existing platforms, still time to keep selling large, heavy battery packs wrapped in luxury branding, still time to frame cold weather loss, charging anxiety, and thermal management complexity as temporary annoyances rather than signs of a chemical ceiling. In the United States, that mattered because the benchmark use cases are brutal: highway miles in Texas, winter mornings in Michigan, long-distance family travel across the Midwest, and the constant pressure to make an EV behave like a real American machine rather than a fragile urban gadget. The old narrative said the hardest battery problems were acknowledged, but not solved. The deeper blind spot was that the industry kept thinking in product cycles, while the disruption was brewing at the chemistry level. Inside China, however, the pressure was harsher and the clock moved faster. BYD emerged as the dominant force of the current generation, with Reuters describing it as the dominant player in China's EV market, while BYD's own materials positioned the Blade battery as a safety-centered LFP architecture built around durability, strength range, and space efficiency. That made BYD the standard bearer of the present EV order, not glamorous chemistry for the distant future, but scalable, affordable, safer batteries in real volume. This is what makes GAC's move strategically dangerous. It is not attacking an empty space. It is attacking the reigning logic of the current EV era. Instead of merely publishing a laboratory breakthrough, GAC's Hyper brand told the market in 2024 that it had finished all solid-state R and D and would begin using the cells in cars in 2026 with claimed energy density of 400 watt-hours per kilogram. That is not a gentle upgrade path. That is a flank attack on BYD's present dominance and on the West's future timeline at the exact same moment. And that is the historical trap for the US market. Detroit learned to watch Tesla. Wall Street learned to model EV margins. Consumers learned to compare range price and charging speed. But the real shift may be happening one layer deeper, where battery chemistry decides not just cost and distance, but the credibility of the entire product class. If GAC can take a globally marketed premium SUV platform and use it to shorten the solid-state timetable from later this decade to on the road in 2026, then the old American assumption collapses. The question is no longer whether solid-state will matter. The question is who gets humiliated first when it arrives in a form the market can actually buy. The first pillar of this disruption is brutally simple. Western EV engineering has spent years trying to manage the weaknesses of liquid electrolyte lithium-ion batteries, not eliminate them. NHTSA's own battery safety work explains that conventional lithium-ion cells can enter thermal runaway through internal shorts, overheating, overcharge, physical damage, or other abuse, and that once the reaction accelerates, it can propagate beyond a single cell. That is why the legacy answer has been layer after layer of mitigation: heat sinks, cell spacing, coolant loops, diagnostics, warning systems, and increasingly complex battery management software. GAC's all-solid-state claim attacks the problem one layer deeper. Reuters reported that Hyper said it had completed R&D on all-solid-state batteries to be used in its cars from 2026, with a claimed 400 watt-hours per kilogram energy density and more than 1,000 kilometers of range. That matters because it reframes the contest. The old question was how cleverly Western automakers could contain the compromises of liquid chemistry. The new question is what happens if one player starts removing that chemistry from the center of the equation. The second pillar is energy density, and this is where the American market should pay very close attention. A 400 watt-hours per kilogram battery claim is not just a laboratory brag. It implies more stored energy for a given mass envelope, which is exactly how an automaker tries to stretch range without turning a premium SUV into an overweight rolling compromise. Reuters said Hyper's target was more than 1,000 kilometers. If a claim like that survives production reality, the consequences are enormous for US driving logic. On a Texas highway run, this is the difference between treating a battery pack like a suitcase that must keep getting larger and treating it like a denser fuel reserve. In Colorado, it changes how much weight you are hauling uphill before gravity starts billing you for every extra kilogram. And in a premium segment, where American and European brands have often responded by adding more battery mass, more thermal control, complexity, and more cost, GAC's pitch is more dangerous because it says the answer is not a bigger box. The answer is a different chemistry. The third pillar is safety, and this is where the script's rhetoric becomes strategically lethal. NHTSA documents that thermal runaway in lithium-ion packs can become self-propagating, can release smoke before flames, and is notoriously difficult to extinguish once it escalates. GAC's own materials for its magazine battery say the pack architecture was built around cell isolation, fire retardant protection, and a shell rated to withstand 2,000 degrees Celsius, and that in nail penetration testing, the company saw no fire or explosion. Reuters, meanwhile, noted the core reason solid-state batteries are so attractive. They replace the flammable liquid electrolyte used in conventional lithium-ion cells. Put those pieces together, and you can see why this narrative is so dangerous in the US market. Truck loyalists and EV skeptics have long used battery fire fear as one of the strongest psychological arguments against electrification. If GAC can combine cell-level chemistry that removes the liquid electrolyte with pack-level safety architecture already marketed around containment and abuse resistance, then one of the loudest anti-EV talking points starts to lose force. The fourth pillar is not chemistry alone, but the skeleton carrying it. GAC's own product and technology materials position the HYPTE CHT around its dedicated AEP 3.0 pure electric platform. Not a converted combustion chassis, and official specifications list a front double wishbone and rear 5-link independent suspension setup. That matters because the battery story only becomes industrially meaningful when the host vehicle is already architected to behave like a real premium machine. NREL's cold weather work shows why this matters so much in America. Low temperatures reduce EV efficiency, and range, and cabin heating, defrosting, and battery conditioning all pull energy at the exact moment drivers need confidence most. So this is the real significance of the Hyper HT platform in the US context. Michigan winter rural charging, long interstate hauls, and mountain grades do not forgive fragile engineering. A dedicated EV platform with mature chassis hardware means GAC is not merely promising a miracle cell. It is trying to place that cell inside a vehicle architecture already built to absorb torque control weight and survive real-world use. That is how a chemistry story becomes a market threat. The first thing to say clearly is that the HYPTE CHT is not a full-size American pickup. GAC's Europe spec HT is a 4,935mm luxury SUV with a 2,935mm wheelbase, a 72.7 kWh LFP pack, AWLTP range of 445 kilometers, and a front double wishbone/rear 5-link suspension layout. So the threat is not that it suddenly replaces an F-150 on ranch duty. The threat is that GAC is trying to use a near 5-meter premium SUV as a delivery system for a battery claim that Reuters said could exceed 1,000 kilometers in 2026 at 400 watt-hours per kilogram. That is what makes this comparison dangerous for America. Not class equivalence, but expectation disruption. Now look at the American benchmark machines. Ford's 2025 F-15. Lightning tops out at an EPA estimated 320 miles on the Lariat extended range setup, and Ford says the extended range truck can tow up to 10,000 pounds when properly equipped. Chevrolet's 2026 Silverado EV pushes much farther on range, up to 493 EPA estimated miles on the commercial page, or 478 miles. GM estimated on the consumer side, and up to 12,500 pounds of max towing. Ram's official 1,500 REV page is even more revealing. It advertises 690 miles of best-in-class driving range and 14,000 pounds of towing, which tells you Detroit's truck war is still being fought through size, battery mass, and brute force capability. That is exactly why a solid-state Hyper HT would be so disruptive. It would not beat these trucks at towing. It would attack the idea that American distance capability must keep arriving in the form of ever larger, ever heavier battery trucks. The more intimate benchmark is Tesla, because this is where the symbolism becomes humiliating. Tesla's official Model X page still sells the vehicle as a luxury electric SUV with Falcon Wing doors, up to 335 miles of EPA estimated range, 5,000 pounds of towing, and a 0.24 drag coefficient. GAC's HYPTE CHT already carries its own rear gullwing door signature, and official materials say the SUV uses 8 radars for 360-degree awareness. So if GAC succeeds in putting an all-solid-state pack into this body, it is not merely entering Tesla's territory. It is challenging one of Tesla's most iconic product ideas, the theatrical premium electric SUV, while attaching to it a chemistry story Tesla has not commercialized. That is how a feature comparison becomes an industrial insult. For the US market, that is the real benchmark verdict. In Michigan winter, NREL notes that cold weather and thermal loads can cut EV performance and charging confidence exactly when drivers need both most. On Texas highways, long range is still psychological armor. On Colorado, grades weight is a tax you pay twice, once in efficiency and again in control. So if GAC can make a premium SUV platform credibly leap from a Europe spec 445 kilometers WLTP configuration to a claimed 1,000 kilometers plus solid-state future, then Ford, GM, Ram, and Tesla do not just face a stronger rival, they face a much uglier question. What if the next phase of American EV competition is no longer won by adding more battery, but by escaping the chemistry that made those giant batteries necessary in the first place? This is the point where the story stops being about one SUV and starts becoming a problem for American industrial policy. Batteries account for roughly 30% to 40% of an electric vehicle's value, which means the real battlefield is not just the badge on the hood, but control over the chemistry, materials processing, and manufacturing stack underneath it. The IEA has framed EV battery supply chains as a core strategic issue, and the U.S. Department of Energy has already committed major money to that reality. DOE says it awarded $1.82 billion to 14 projects to expand battery material extraction, component manufacturing, and recycling. And in March 2026, it announced up to another $500 million for critical material processing and derivative battery manufacturing and recycling. That is the scale of the warning. Washington already understands that battery chemistry is no longer a side story to the car business. It is the industrial base. Now add tariffs, and the picture gets even more revealing. In May 2024, the Biden administration sharply increased Section 301 tariffs on strategic Chinese imports, including raising tariffs on Chinese electric vehicles to 100% and on lithium-ion EV batteries to 25%. That can slow direct import pressure, but it does not solve the deeper threat. Tariffs can block a vehicle at the port. They cannot protect a weak timeline, an inferior chemistry roadmap, or an outdated packaging philosophy. If GAC or any Chinese automaker proves that a road-going premium EV can move solid state from someday to 2026, the shock reaches the US market even if the vehicle itself never arrives in volume. It reaches investors first because valuation models begin to change. It reaches product planners next because battery roadmaps start looking late. And it reaches consumers last because once expectations shift, every existing premium EV starts to look like an expensive bridge technology rather than a destination product. Then there is labor, and this is where Detroit should be paying the closest attention. Reuters reported in February 2024 that the UAW committed $40 million over 2 years to organize U.S. auto and EV battery workers, explicitly targeting the expanding battery workforce. That matters because the EV transition is not just about swapping engines for motors. It is about deciding where the next generation of high-value manufacturing jobs will live, under what standards, and around which technologies. If the next major leap in cell chemistry happens faster abroad than expected, American Union strategy plan, investment, and supplier planning all come under pressure at once. Worse, solid state is still hard. Reuters has repeatedly noted raw material constraints, intricate manufacturing processes, and high costs as major barriers to mass adoption. So the danger is not simply that America loses on cost. The danger is that America gets trapped in the middle, subsidizing current battery infrastructure, while the next chemistry curve begins rising somewhere else. So the real geopolitical question is no longer whether America believes in solid state. America already does. The real question is whether the US can compress its response fast enough in critical minerals battery manufacturing, worker training, product planning, and commercialization discipline before a foreign chemistry breakthrough turns from a headline into a market standard. Because once that happens, tariffs become defensive walls around a lagging product cycle, not a strategy for industrial leadership. And that is the question hanging over Detroit now when the chemistry war stops being theoretical. Will America react like an inventor or like a customer, arriving late to its own future? What happened here is bigger than one battery announcement and more dangerous than one premium SUV. Reuters reported that GAC's Hyperbrand said it planned to begin using all solid-state batteries in its cars in 2026, with a claimed energy density of 400 watt-hours per kilogram and more than 1,000 kilometers of range. At the same time, the HYPTE HT is not an imaginary show car. GAC already markets the model internationally as a real premium SUV platform. That combination is what turns this from a technology story into an industrial warning. The old Western promise was that solid state would arrive later, after years of delay, cost reduction, and controlled rollout. If GAC shortens that timeline on a vehicle architecture, the market already recognizes then the age of selling expensive compromises as premium innovation starts to look very fragile. This is why Detroit should not read the Hyper HT as a foreign curiosity. It should read it as a warning flare. The industry told America that the hardest battery problems were still over the horizon. But Reuters' broader reporting on solid state made clear that global automakers have treated the field as the next holy grail, even while commercialization remained elusive. If one company starts moving that prize toward the road faster than expected, the balance of power does not shift politely. It shifts by humiliating every product plan built on the assumption that chemistry would stay frozen long enough for the legacy order to adapt. This is how an era ends, not when the old machines stop working, but when the next technology makes them look old before they are finished being paid for.